Here comes one of my favorite tricks, the Remesh Modifier. In this lesson, I show you an insanely quick way to turn our curve-based, self-intersecting mesh design into a solid, cohesive 3D printable mesh, from mess to mesh. Just a simple modifier that makes our model watertight and ready to 3D print in seconds or minutes, depending on how quick your PC actually is. This trick is a game changer when you're working with complex curves that need to be 3D printed. While it's not for remeshing in game design, it's not like we're building a new topology that is usable for textures or stuff like that. It's perfect for jewelry and other printable designs where booleans are just very, very time intensive. So let's jump in and watch this modifier do its literal 3D magic. So you've come this far, you have built your dream ornamental ring design, and hopefully you learned something along the way. So this next step is super important if you have placed the stones somewhere and they look dull, just as they do here on our design with the ornament and on the side, and maybe also some of which we placed in the holes. This means basically we need to cut some holes into this ring for the stones to look realistic. And you also maybe would want to do this if you eventually would want to 3D print your ring. Depending on how you want to process it, you might want to have a hole where the stones are sitting pre-drilled, so to speak. So in any case, we would have to do something with this ring to make this possible. In short, we will convert these curves to mesh and then combine all of them, to be then able to bool those stone holes out of there. There are multiple ways to do so, but I will show you one of the easiest and by far the quickest one. So make sure you save a new version of your latest creation, since this process is destructive and will not allow you to make changes on the curves as before. Maybe call the save file voxel remesh or something, because that is what we're going to do with this ring. First, let's hide the stones for a second. Also hide the render. And maybe right-click in between those join areas and hide the render view completely for now. By the way, you might have noticed that I have some statistics down here, and this is quite helpful if you want to know how many verts and trees, if you want to keep track of them and how many objects there are, also how much memory your file is using. And you can also turn statistics on in the overlays, then they will appear here. But if you want to see those statistics down below on the right, you can just right-click on this lower bar and turn on the scene statistics. Select all the curves that you use on the ring map, the ornaments, the outer edges, and so on. So you can go into the outliner, right-click and say select objects, then you have selected all the ornaments, and then shift and click on the outer edges. Now right-click somewhere and choose Convert to Mesh. This will instantly apply all the modifiers and convert all those curves. You might notice if you select this piece here, it hasn't got any modifiers anymore. It is also not a curve anymore because now there's this mesh data tab and not the curve data. It also has become a mesh. You can see all those triangles here on the ornaments. They are not curves anymore. And that also means if you go into edit mode, you will see that this geometry has now become a mesh and they have individual vertices and they are not easily changeable and malleable like the curves were. Okay, we will need to do a second step, so reselect everything here and now press Ctrl J. Now this whole thing here has become combined in one object. If you go into edit mode, you will see they are all there. You can edit them all individually, but if you hover over one of them and press L, this means select all linked to this one vert that you hover over there, you will see that these are still individual pieces. They're not yet combined. Okay, so this is one object, but there are many different meshes in here, which you could, if you select one of them, move individually. So this is one big object. And the final step that we have to do to make this actually into one watertight 3D printable and boolable mesh, you go to the modifiers and you go to Remesh. And this instantly looks quite different because our voxel size is quite high still. It's not very fine grained. But if I turn that off for a second, you may notice that all these pieces, they kind of overlap themselves and each other. Okay, so they all are stuck inside each other. And if I turn the Remesh modifier on, you might note that this all has now become a continuous surface. So all these self-intersections and these overlapping parts, they have just become one giant mesh. So if we take this down a little bit to, let's say, 0.05, you will see that the details become much finer. And if you go to 0.02, be careful because at some point it will take quite a while for Blender to calculate that. You will see that it nearly looks as before. And if you now go into the render view, you will see that it also has become quite nice and glossy and all the pieces are now stuck together. All right, if you are happy with how that looks, you can go and save another version of that. The thing is, if you now notice that here are some kind of jagged curves, they are not as finely detailed as you like, you can just repeat that process and you go back to the file as it was before when we still had all the individual curves and make sure that you say shade flat so that you see the actual surface, and then you could give this a subdivision surface modifier before you convert it into a mesh, and then the surface will be much smoother even after you remesh it. Okay, so if we go back to the remeshed version, I feel this still looks quite nice. I'm happy with that. You might also notice that now you have a lot more, you can turn on the statistics here as well, a lot more triangles, faces, edges. Before the remeshing, this is like only a tenth of that. So this object has become much bigger now than before, but of course we can deal with that later as well, because we could now export it as an STL. So that would give you a printable file. Okay, so you could just get yourself a new folder, call it STL, selection only to not export anything else that might float around there, and then export STL. But that would make the STL quite big. It will also take a long time to generate it. And there you have it. So it's nearly 0.5 GB, and that's pretty big. Of course, we could just open that in a slicer now. If you have, for example, the Prusa slicer, which is awesome, and I always use it for 3D printing. And there you have it. So it is completely printable right now. And that's the cool thing about this technique. But if you don't want to have such a big file, we have one trick. And of course, you might know this already if you followed me for some time. But if not, let's check it out. So first, to reduce the file size, let's first apply the Remesh modifier and then give it a decimate modifier. So now we have baked this kind of this shape. And now we want to retain the shape, but we want to have a lot less vertices. So notice we have around 8 million triangles. And if we turn that down to a ratio of 0.2 or something, so we just bring it to 20% of how many vertices and triangles there are, while Blender still tries to retain the look of it. And that also can take quite a bit of time. All right. But now you see that we have brought this down from 8 to 1.6 million, and the ring, fascinatingly, still looks the same, which is really nice. And then we can apply this decimate modifier, and this also brings down the file size, which can be quite important if you're working with such big objects. Well, it's not that big in the real world, but big in the sense of how complex the geometry is. Then it's nice to be able to decimate it so that you can keep your file size low.
1 minute later.
And there you go. And now if you export that, just to prove my point, if you export that STL, maybe with a decimate at the end of its name, and you export the STL, it will not only be much quicker, but it will also be much smaller. There you go. So it's now only 20% of the original size, and maybe you can go even lower to 10%. But reducing the vertices always takes some time, so keep that in mind. Okay, so now that we've done that, and it all seemed to have worked out, we have one single piece of ring, which is also meshed together. By the way, if you have some problems because somewhere something's stuck through the surface which shouldn't, you can actually just go into sculpt mode and maybe go over there by holding shift with any brush and smooth it out. Okay, so that would be a very quick way of fixing such minor errors without having to go through all the previous stuff again.